My name is Miley Webb. I am the Webmaster and Electronic Communications Chair for the Alaska chapter of Ashrae. We had a panel of 4 gentlemen who are the icons of Alaska for our January chapter meeting. We had the privilege of Bill McNeal, Boyd Morgenthaler, Steve Theno, and Dick Armstrong. For more information, questions, or if you'd like to donate to our Alaska chapter, please visit us at ashraealaska.com.
We really want to actually take a minute to welcome our distinguished panel of speakers to Ashrae this month. These 4 gentlemen have a combined experience of over 200 years of experience in HVAC and mechanical engineering design. They've designed many, if not most, of the major projects in Alaska over the last 30 years. They represent a large part of our history of mechanical engineering in the state of Alaska and Ashrae. We've had their bios going on in the background here, and they'll continue to run as we go through this. But we have Dick Armstrong with RSA engineers, Steve Theno from PDC, Boyd, I get the names wrong, Morgenthaler from AMC, and Bill McNeal from Coffman Engineers with us tonight. So please take a moment to welcome them. We've got 6 questions we'll go ahead and start with, and then I'm going to open this up to you guys for any additional questions. So if you have some that you'd like to, please let us know. We asked a lot of our younger engineers for these questions. But what is something about the career in engineering that surprised you? And do you want to start, Dick?
Well, I just didn't think it'd be as much fun as it is. But I started engineering in aerospace in a factory making inertial guidance systems, and you saw the same stuff every day and the same problems every day. Came up to Alaska to work on the pipeline and got into construction, and everything is different every day. And then getting into mechanical engineering and electrical engineering was really a blast. And I still work about 10 to 20 hours a week just because I enjoyed it. So I'm really not working at all. So bottom line, it's a lot of fun. I enjoy it.
When I saw this question, I think the first thing that came to mind that surprised me about engineering was all the other stuff that goes with it. Engineering is a beautiful thing, and it's a lot of fun, like Dick says, but the engineering business involves all these other things you have to do, like specifications and contracts and construction claims and budgets and schedules, architects, all those other things that come along with an engineering project. So, and lots of times it was those other things that really made the project complex or became really a bigger part of the job.
Very true. I think the thing that impressed me most when I started was just how totally unprepared it was. It was amazing. I had a good education. I'd done an internship. I had a lot of practical experience. But when I started, I couldn't engineer my way out of a wet paper bag. I swear, it was really frustrating. But one of the things that I learned, and I believe this, it's not said often, I don't think, but the consulting engineering business is like a guild. You know, there are masters and then there are apprentices. We start off as an apprentice and we don't know anything, and over time we learn and we study, and then eventually we get it, but it's a long process. I didn't have any clue about that one.
Yeah, I can kind of agree with that, and how green I was when I first started. I can remember taping that first sheet of linen drafting film down to my table and getting out a straight edge and a scale, and everybody kind of standing around showing me where to put the pencil down on the sheet. But anyway, that was a few years ago.
I'm not sure anybody knows what linen is, Bill,
Yeah.
in this room today.
It's a drafting film. It's made out of linen cloth, and they starch it, and you draw on that. If you ever want to see something, I got a roll in the office. I still use it. It doesn't work very well without a cat. Anyway, I think the thing that surprised me a lot about engineering is how little of what I learned in school really applies. Now, granted, to be an engineer, you've got to go to college. You've got to take some science classes, and you gotta take some thermodynamics and whatever else goes along with it. But where the rubber meets the road, at least in our corner of the industry, only about, what is it, less than 5%, 3% of mechanical engineering graduates go into HVAC, vertical construction design. And so not every school can have more than a couple of classes in HVAC. Now, there are some exceptions. There are half a dozen schools around the country that have a strong concentration in HVAC. Unfortunately, I wasn't smart enough to figure out where those were and go to one of those. But anyway, college, even if it doesn't teach you exactly what you need to know, certainly is a screening process. You can't get through most colleges being an idiot. And although sometimes I relate with the idiocy when I see all these sharp young minds coming into the industry, the young fellows that, and I'm looking at a couple of them right now, that come in out of school and how smart they are and how much better they are prepared to deal with the electronics and software and computers, and I'm just at awe with that. I struggle with that every day. So
The change. What's one lesson or saying that a mentor taught you in your career that still sticks with you today?
Oh,
Let's start with Steve.
all right, sorry. Okay. So I guess the one lesson that I got from my mentor that made a big difference was he advised me that your career success is really going to hinge on recognizing and supporting and empowering the people that you work with. That engineering is done as a team, and if you're going to be successful, that team has to be successful, and you really have to do your part to support that team. And I think that's served me well through my career. And if I could add another one, this is kind of a strange one, but he also told me about, when you're communicating with, in engineering, you're going to have to do a lot of communication. And you're going to spend a lot of time persuading people to take on to recognize a certain point of view, or negotiating, or compromising on issues. And he said, as you approach communication, an issue like that, you can, when you pick your words, you can pick war words, or you can pick negotiating words. And if you pick war words are like, absolutely not, no way, that's ridiculous. Or, of course, negotiating words go the other direction. But if you pick war words, the communication is almost over right when you start. If you pick negotiating words, you have an opportunity to persuade people to your point of view and share ideas. And I saw that happen a lot in the course of my career, where someone started out a conversation with a war word, and immediately the defenses went up and the communication really stopped.
Well, Steve, you kind of took the words out of my mouth, because I'm thinking learning from others. You might think you have the only answer or the only solution to a problem, and there's a lot of different ways to skin the cat here. And I've learned to listen to other people and respect what they have to say. Maybe they're not right, but at least listen to them, and then reinforce what you have to say.
Can't disagree with any of that. This question just sort of brought back an early childhood memory, and I'm not just not as probably as prophetic as what you guys are talking about. I remember my dad was an engineer, and all of his friends were engineers. When I was in grade school, he told me a joke. He says, "What's the difference between a doctor and an engineer?" You guys have all heard this, right? And the answer was that a doctor buries his mistakes. An engineer's mistakes bury him. And of course, everybody laughed, and I thought it was it was funny at the time, but it kind of stuck with me. So when I got my first job, didn't know anything, and I had this mentor, a fellow named Ernie Peck, native electrical engineer from Wasilla. I was down in Seattle. Ernie was a great guy. he basically got me up and moving and got doing things, and we were ticking along. And after a couple of years, he quit chewing on me so much, and things started to come around. So I walked in the office one day, and he handed me this certificate that he made. And it was my first Attaboy Award. That Attaboy Award, it says, to qualify to be a leader of men, work overtime with a smile, explain projects to management, be looked upon as a local hero who must earn 1,000 attaboys. That's my first one. Yeah, so then at the bottom it says, no, it says, one eye shit wipes the slate clean and you gotta start all over. So, I don't know, I guess the reputation there is, our reputation is everything, is part of it. It kind of ties back to the engineer's mistakes burying them. But there's a corollary in all of that that I think is really probably the most important. And that's that all of us screw up sometime. We all do. And the measure of us is not whether we screw up, it's how we handle it. And if you have a problem, lots of times it's a team problem. You just have to find the people around you and go out and solve the problem. And the first thing you have to do is park the blame, forget the blame game. Forget about who caused it, why it's caused, what's going to cost, whatever. You have to just get in, figure out how to solve the problem, find the most efficient solution possible. And once the problem's solved and you have an efficient solution, all the rest of that works out. And if you're lucky, you won't get an aw shit.
Well, I guess one of the things I sticks in my mind over the years, and it was a long time ago, I had two mentors actually, when I first worked in a consulting engineering office, and one of them sat there and one of them sat there. A licensed engineer that was about 10 years older than I was, and a seasoned designer that was about 20 years older than I was. And they all had lots of good information. We were working on the same projects, and there'd just be this dialogue going on constantly about what's going on, what you do there, and I could ask a question, and they were right there to answer it. But one of the biggest things they taught me was managing your time and estimating how long it would take to get something done. Because frequently we have a lot of pressure to get things done yesterday, and if you aren't managing your time and can't estimate how long it's going to take you to finish a task or a phase on a project or you're part of the project, it can hold everybody else up. And that's one of the things I see in a lot of other young engineers, like I was young, but fortunately I had two people that just hammered it into me. How much are you going to get done today? You have to have this sheet of drawings finished today before you can go home. Next Friday, you have to have this amount of work done. So I was taught right from the get-go, almost as soon as I learned how to run a ductilator, to manage time. And I think that's one of the things that I still struggle with it in some cases, but that's an important skill to have, and it's something that my mentors taught me early on.
So what advice can you, talking about moving on and moving up in your career, what advice do you give somebody who wants to move from a design engineering position into management? Because each one of you kind of made those leaps and jumps as you went forward into your careers. So what would you say to somebody who wants to do that?
Well, you got to be able to do about three things. You got to be able to make it rain. You got to be able to walk on water. Other than that, it's easy. I think one of the biggest things is as you start going into management, you are less and less of an engineer. And if you're the head person in your firm, plan on, you can almost kiss your engineering degree goodbye, because as Boyd said earlier, you're taking care of the insurance, you're taking care of contracts, you're playing part-time attorney, reading contracts, managing people, and unless you're going to work 60 or 70 hours a week or 80, you don't get to do much engineering. So Be prepared for that. And the other thing too is you have to have real people skills. You're never going to be a successful manager or leader of a group if that group doesn't want to follow you or if you don't treat them well. And that's, I think, where some heads of state, I'll call them, that move to the top can sometimes be ruthless. Fortunately, I've never had to work in one of those situations. I've seen it happen, though. And so if you want to be management, you've got to be there to serve every person that's working for you.
I would take a little bit different view on the difference between engineering and management. I agree that as you get more into management, you're doing less design. Design, really, you have to have your head into a lot of pieces and parts and where this fits and that fits. And you kind of lose time for that. But for me, as my whole career progressed, I became more of an engineer, not less of it. I feel like I'm more of an engineer now after retiring for 8 years than engineering is a process, and it's a mindset, and it's how you approach problems. And to me, the ability to approach a problem and take 1,000 moving pieces and get them to all work together, that's engineering, whether you actually did it all yourself or not. So I think for somebody first moving from a design position into management, the number one thing that I would get them to, that I would counsel them on, is that consulting is a business first and foremost. We are not engineers that do business on the side. We're business people who have a product which is engineered. And a person that's in management has to have that in their head. If the product isn't profitable, your engineering solution isn't profitable, you better find a different thing to sell because you're going to be broke. If you can't make a profit, you can't serve your customer next week or next year. You have to be profitable, be out of business. And you're not doing anybody any good if you're out of business. So the other thing is that you got to make your customer happy with the product. Right? So there's a balance there. So the thing that a person needs to learn is what I call TQM. It's not total quality management. It's time, quality, and money. Every project has a balance between time, quality, and money. So it's kind of like a camera, you know. If you want, you adjust certain things, and you can only adjust 2 out of the 3. So if the guy wants it tomorrow, he may have to give up on quality, and you know, he may have to pay you a whole lot to go find every engineer in Anchorage to help work on it and get it done. So shorten up the time, the money goes up, the quality goes down, and you have to find, if you want perfect quality, well, it's going to take a lot of time and probably a lot of money. So you got to find that sweet spot. So as a person starts, you need to kind of know where that spot is right from the beginning. This is what Bill was talking about earlier, about, you know, how much time is it going to take you to do the job and what's it going to cost you. So you have to figure that out early on. And if you don't have a good solution, if you can't figure out how to deliver the quality that the owner wants on the schedule that he wants for the budget you have, well, you better go back and negotiate. You just cannot ever afford to deliver a bad job. That gets back to the engineer's mistakes bury him. And if you get in a big hurry to do something, it's not good for you. So I just say never get trapped in an artificial time, quality, and money conundrum. There's a solution, and if the solution means you need more one or the other, then go get it.
Yeah. So I think I thought when I thought about the question about moving from doing engineering to management, what came to mind is that I think management is really, I mean, it's different. It's a different focus. It takes a different skill set. And you still have to be able to do engineering. That's important. In fact, you probably do more engineering, as Boyd suggests, than you did as the design engineer. But it's still a different focus. You're not the doer anymore, meaning you're not doing the detailed design. You really have to become the maestro. And that's why you need to know even more about engineering so you can do that. You need to be able to set the course, you need to be able to offer guidance, and then you need to be able to delegate and really empower the doers that are tackling that particular project. And when you think about that, then I think in management, the most important thing really is to understand the people that are a part of your team. You have to really know what their expertise is, what their strengths and weaknesses are, how they make decisions, what they consider important, because you're really, as a manager, trying to ensure that that team, that group of folks, can really excel. And in order to do that, you've got to lead them, and you have to be able to understand what their capabilities are and provide all the support you can to really allow them to excel.
Just mentioned a lot of the ideas that I wanted to bring up as well is, when you become a manager, you've got to be able to choose the right people, and then you've got to be able to delegate and trust them. But then you have to peer review and coach them along, pay them well, understand their concerns, and sometimes you got to help them with their personal problems, whatever. But that's the way you get a team, because when you're a team and when they're hurting, you're hurting, and when that team has to meet a deadline, we all work and stick together and do it. So I think we're all pretty much saying the same thing. You got to get everybody together on your side, and they all want to get the job done and get it done well.
Mm-hmm.
So with that being said, what's one or two lessons specifically you learned that you had when you became president, or leaders of your departments or areas in your companies?
I did a lot of work with Harley Hightower. One thing he taught me was be prepared. As was mentioned before, everybody makes mistakes. It's how you solve that problem. And, if you want to stay in business, if there's a problem, everybody's going to make a mistake. But you got to stand up and fix the problem, get out the checkbook if that's what it takes. And like I was mentioned, don't be passing the blame around, but find the solution and make sure that the customer is happy. And I think you'll be okay.
So I guess one of the lessons learned I had, and there were a lot of them, but in my leadership role as president in the firm there for a while, was it was really important to establish a really clear and succinct mission and vision. I know we all talk about mission and vision, but really you need a clear and succinct mission and vision so the whole team is pulling in the same direction at the same time. Everybody knows what they're doing, what the goal is, and where you're headed. Otherwise, you have a group of people that head off in all kinds of different directions all the time. But the corollary to that was, once you set a mission and vision, you really have to do it where you get buy-in from the whole company, the whole team. And getting buy-in is not that easy. That takes a lot of work. But if you don't get the buy-in, then that mission and vision is going to fall apart pretty quick. And the other piece of that is, once you do have buy-in and you do set a mission and vision, it takes a lot of work to continually reinforce that mission and vision, because usually they're fairly succinct, simple, straightforward statements that really shine a light on what you're doing and where you're going. But it's just amazing how quickly we all kind of forget about that in the heat of the daily battle. And someone has to be reinforcing that all the time so that company moves in the same direction. And then I think I would add to that, so setting the mission and vision I think is really critical. And then the other part is to make decisions, and make decisions quickly. You have to think about the decision you're making, You have to get good input for it, but it's a lot better to make a decision that everybody's aware of, that enables the company to move forward with a single kind of mindset. Even if after a while you begin to reassess and think maybe the decision should be modified slightly, that's okay. It's all right to make a decision and then down the road reassess and make some changes. But it's really going to be unacceptable if you waffle without a decision for a long period of time. People don't know what direction to go in, and then you begin to get a lot of different stratified views. So I would say set a mission and vision, and it's going to take a lot of work to set it, but you got to set it, and then you got to reinforce it and make clear and fairly rapid decisions when a decision is needed.
Yeah, I wish I'd thought that right down about the vision and mission, because I agree with that. And making decisions is really an important factor of being president, or even being anywhere in the upper management of the company. One of the things that about decision making at the organizational level is they're just like any other engineering decision. They really are just like any other engineering decision. You've got to empower, you've got to enroll all the brain power around you. You've got a lot of brain power around you. You've got senior managers, senior staff, and even junior staff. Everybody's got some ideas. You have to gather those thoughts, and you're surrounded by smart people. You have to use them. And so when it comes to making a decision, you do the best you can to come up with an answer. And just like any other engineering decision, you get it peer reviewed. You have to make sure this is not a democracy. You're not asking for a vote, but you want to make sure that when you make that final decision, it's the right thing for the organization. So that takes a little bit of thinking. And sometimes it gets a little lonely at the top, it does, because you may not make the right perfect decision. None of us are perfect. We don't always make the right decision. So if you make a mistake, you just have to go back and fix it. And you just don't let the hard decisions eat you up. I want to shift gears a little bit. A lesson about being the president, and it really goes to a lot of things about the engineering business, is that the president is the business's face in the community. We've all been there. People look to you as the president, as a representative of the business, and so the president needs to develop positive relationships with as many community leaders as they possibly can. But it doesn't start the day that you become the president. You become the president because you started that decades before. So, that's something for you all to think about this, is that, someday, you may be upper management, upper leadership, but those relationships you have in the community, you need to start cultivating now. Now, technical societies like this are great because you get to know each other. But the average person only associates with people in their own discipline. HVAC engineers associate with HVAC engineers. I don't see very many electrical engineers in the room. There are some. But
We won't hold it against you.
You need to get out beyond the technical stuff. The best way to learn how to lead, that's a great thing. How do you learn how to lead?
Do it.
It is, I think, the easiest way in the world is just go out and become a youth sports coach. Try that sometime. And if you can ever figure out how to get the kids all going in the same direction, Then you can try to figure out how to get all the parents to go in the same direction. And you don't have any situational power over anybody. It's just your ability to talk them into it. So it's great training. You can learn the dynamics of a large group by getting involved with a nonprofit organization. Get on the board of YMCA or the board of the Boys and Girls Club or whatever, and you'll get all kinds of different people in the community, and you quickly learn that it's not your way or the highway ever. It's what can you convince people to do. So that's a good one. Personally, I'm a Rotarian. I really like Rotary, and I would encourage you all to become Rotarians. The object of Rotary is it's community service, but what it really is that the opportunity to meet people in other vocations. There's a concept in Rotary called the worthy vocation. There are literally hundreds of worthy vocations. The guy in the Rotary Club is in the asphalt paving business, and I'll tell you, that's a worthy vocation. There are people who are veterinarians, people who you got attorneys and doctors and engineers, of course, but you've got all kinds of different business people and people that run restaurants and all of that. So in the process of getting to know people in the community, it helps you understand more about the needs of the engineering business, because we are here to serve the community. So I would recommend that as a place to start.
Well, that's the problem with being last. They've all said the good things already. Yeah, I agree with everything you guys have said. I'm going to go off on a little different tilt. I was never president of Coffman Engineers. Our president lives in Spokane. I was president of a previous firm that I was with for about 18 years prior to coming to Coffman. And it was a mechanical only firm. And we had about 25 people, I guess, maybe 30 at one time. That was down in Portland, Oregon. Well, I came up here and managed an office in Anchorage with that firm. When the bottom dropped out of things, if you guys remember when that was, I hightailed back to Portland and then came back up here again a few years later. But one of the things that was a challenge for me, because I'm not as much of a people person as I probably should be, and assessing your crew and the people that work for you, and like it's been stated previously by these guys, everybody's got strengths, everybody's got weaknesses. You have to know what the strengths and weaknesses of your various people are, and try to, the ones that are a little deficient in some areas, you try to bring them up a little bit, but you try to take advantage of all the strengths that people have. Maybe you put a couple of people together, the one is less experienced in some areas and one is more experienced, to try to let them bleed some of that training and mentorship off. The other thing that I struggled with a little bit, but I think I finally got it, was you need to know where your weaknesses are in your organization and be proactive in trying to find people that can fill that weakness. If you need somebody from a different discipline and you don't have that discipline, or you have one or two people in that discipline and you need more, be identifying what person it is you want to fill that slot, what their characteristics are, not just that they're a licensed engineer or whatever. What kind of person are they? Are they outgoing person? Are they somebody that likes to sit there and split wood and stack it up real neat? And you need a lot of those. They aren't necessarily outgoing, but they're reliable. They come to work every day. They work long hours when they need to, and their work is always good work. But you don't put them in front of a client. And so those are some of the things, just assessing your crew and evaluating their strengths and weaknesses, and using everybody to, as best you can, to their strengths.
So taking a quick shift here, I think something all of us are kind of interested in is, where do you guys see from where you've been, where do you see engineering going in the next 10, 20 years?
I think there'll always be a need for good engineers. Think about it in troubleshooting or sales or design, or there's so many aspects of the engineering that in the HVAC industry that there'll never be a shortage, I don't think, of projects for people to do and work for people to get. And I really have enjoyed it, and I think it's going to be a good future for anybody that wants to get into it.
I thought this was a great question, and my perception is that engineering is just going to keep getting more and more interesting. There's so many dynamic things going on. It's just really cool. I kind of wish I was still in the game. Technology has always been a driver, and technology just keeps accelerating. And a lot of it has then applications in the engineering work that we do. And there's so much that I think is going to become mainstream in the next 10 to 20 to 30 years. It's just super exciting. I mean, artificial intelligence and robotics and all of that is going to make a big difference in the kinds of systems or solutions that we come up with. But a couple of really big ones, or a really big one I think is 3D printing and value-added manufacturing. I think those technologies are really going to change the solutions, the way we approach design solutions, especially in vertical construction, and it's really going to change the project delivery methodologies. And I don't know to what extent the societies or the codes and standards are beginning to address that. I think it's really interesting to think about how you would specify a 3D printed piece of equipment or material or application on a particular project. Whether it becomes proprietary or not, whether you base the whole design solution on assuming 3D, and then if it's not pursued 3D, what does that mean for the solution that you develop? So I see a lot of really interesting things coming along in that area. The other one is everything is moving more and more towards data-driven decisions, and the amount of data that we have just keeps mounting, and it becomes more and more real time. And you can almost envision, like in the scenario of HVAC, you can almost envision a scenario where pretty soon every occupant of a building is going to be tracked by a building automation system. And what it's really going to be doing is controlling the microenvironment that follows that occupant through the building, and it's different for everyone. I think there's some really, I'm not sure that I'm really looking forward to that. It just seems like it's just inevitable. And then the other one I would mention is climate change. I think climate change is really kind of like a game changer, right? It's a different thing. At least through all of our careers in engineering, a lot of things changed. Technology changed, and public policy changed, and access to energy sources changed. But what didn't change was the things that we designed to in the environment were considered a constant. They didn't change over the life of a facility. But now that's changing. The environmental factors that affect that a building has to respond to, or a piece of infrastructure has to respond to, is changing over the life of that facility. And potentially it's changing more and more rapidly as the facility gets older and older. And that's going to take, I think, a different approach to how we come up with design solutions.
I agree. There's going to be a lot of revolutionary change coming up. And I agree that a lot of it is going to be artificial intelligence, artificial general kind of impacts. Those are all really data driven. A lot of data. Things figure out how to analyze it. Obviously, control systems is going to be the easy low fruit to be picked. eventually, I could see CAD programs where you paint a pathway for various systems and figures out the optimum pathways to keep everything from bumping into each other in the least cost project. But it's just like anything else, garbage in, garbage out. And so I don't think smart human being is going to become obsolete. There are going to be a lot of opportunities. As I thought about this, I thought, well, in the final analysis, there's not going to be any change at all. There's just not going to be any change at all. And the reason I say that is that we're not scientists. We're not out there changing stuff. We're not saviors of the world. Our job is not to go out and save it. We're technical servants, really. We're like doctors and dentists. And our business is a relationship-based business based on trust of the customer. So, our job is to understand the needs of our customers and to help them come to the right buying decision, regardless of what the technology is. They don't know what that technology is, and they're asking us to help them figure out the best solution for their project, for their budget, for the time that they have, today. There's always going to be a demand for us to help them sort that out. So, however it evolves, at the bottom line, the human process is going to stay the same. And the way I look at it is that if you take away the technology, there's really little difference between us and the engineers of Rome or Egypt. Same problem. Technology changed for thousands of years. Engineers had different responses for thousands of years, but it's a process. And that process isn't going to change. And that's where my whole concept of it being like a guild. You find people who have mastered the process, and you try to figure out how to steal the trade. Someday you're the master, and the old master's gone, and somebody else is trying to steal the trade from you. It goes on.
Life goes on.
Yeah, what Boyd just said kind of triggered something with me, that engineers are problem solvers. They always have been and always will be. And the problems change. And so you use the process that we were taught and the generation ahead of us was taught, and you guys and the next generation are being taught, is how to solve problems. How do you logically approach it and then come up with solutions? So that's not going to change. I think we're going to be seeing a lot more detail in what we do. Things have to be more precise, and we're capable of doing that with all the electronics and the computers and software that we have. Sometimes I wonder about the cost effectiveness of the way some of that's applied. But I think to tag on something that Steve said about our buildings are going to change. And one thing that I've tried to instill in people is when you do a design, try to make it flexible. Try to think about how things might change in the future. Is our ductwork going to be totally different? Or do we have to take out what's there and put something else in? Do you have space to do that? And I know getting a lot of extra space is something that we all fight for as mechanical engineers, and architects hate us for it. But I think just making sure that your design is adequate to do the job, but if the needs of this building change 10 years down the road or 20 years down the road, do you have the flexibility to make that change? Back when I first started, you didn't have computers. You didn't have the heat load from computers in your space. You were using 2.5, 3 watts a square foot of incandescent lighting or maybe fluorescent lighting, and that's got more efficient, but then you put all the computers in there. So in the long run, maybe it's about the same. But of course, the computers are getting more efficient too. But I think it's just a matter of being open-minded about what it is that we do. I think when I got out of school in 1971, they told us that the half-life of engineering is 5 years. which means that in 5 years, half of what you just learned in school will be useless. Well, I don't know if 5 years was the right number or not, but I think that might be accelerating. That might be 3 years now. Just looking around at the changes that have taken place just in the last 10 years. You know, BIM has come in and a lot of other software and needs for energy efficiency and solar now. Well, lo and behold, you can make solar pencil on some jobs. Those kinds of things are going to be there. And I think energy efficiency is never going to go away, even if we decide that the United States has way more energy than it can use and sell. I think energy efficiency is still going to be something that that we're going to continue to tighten up. How much more, how much further can we go than Ashrae 90.1 plus 30% or minus 30%? There may be a point there that you can't go beyond, but I think it's always going to be important.
What is one thing that you would recommend to young manufacturers representatives?
Join Ashrae.
I got that.
Really, you know, as an engineer, I learned so much from the mechanical reps that were there, and you know, if we work together and we know what you produce and you educate us, you know, we have these lunch and learns that the reps are always putting on, and they're very valuable to the engineers. And so I think Ashrae, for me at least, you know, I went through all the chairs and I was on the thing systems handbook and stuff like that.
And as a fellow.
But Ashrae really helped me figure out what's going on, and so I mean that seriously.
Yeah, I agree with what Dick said about know your product, represent it accurately, and get out and knock on the doors of the engineers and the contractors. And some of our reps here in town do an excellent job of that. You can call them. If they're not available, they'll get back to you the same day, have good answers, help you select equipment, provide manufacturer software, but get out and knock on the doors and get to know those people. Lunch and learns are a good way to do it. And there are a few reps around that we deal with. Some products aren't even represented in Anchorage. They're out of Portland or Seattle or someplace. And some of those reps do an excellent job, even though we may only see them once a year, but they communicate with email and whatever. But we like to support the products of the reps that do a good job and keep us informed. And so that's what I'd recommend.
I think I'd throw out something that's maybe a little bit more generic, and it's been something that's been talked about, kind of been a theme through the whole discussion, but I'd like to reinforce the communication and the communication skills. And I think whether your course in the profession is an equipment representative or design engineer or manager, that those communication skills are just so critical. You have to be able to communicate with your stakeholders, and I would emphasize that it shouldn't just be written, although I think when engineers come out of school, they need a lot of help in written communication, but it needs to be verbal as well. And like Boyd said, getting involved with Rotary or organizations like that really helps. And I think it needs to be visual. So often, you know, engineers communicate with their stakeholders visually, and engineers are really good about putting up a lot of detailed diagrams, but to the stakeholder, they all look the same. They're lines with some circles and squares, and they're very meaningful to all of us, and they mean almost nothing to the person that you're really making the presentation to. So I'd really emphasize that.
Well, my answer is a little bit philosophical. As consultants, design consultants, engineers, consulting engineers, our job is to help our customer make the right buying decision for whatever they're building, whether it's the right HVAC system or the right piece of equipment or whatever else. So as an extension of what we're trying to do, my request for any equipment supplier is to help the customer make the right buying decision. So as a salesperson, I don't want you to sell me anything. I want you to help me make the right choice. And if the right choice is not use this product, I need to know that. If the right choice is my competitor's product, I need to know that too. And if you're helping me make the right decisions, I will call you back every time, whether I bought your product. And in the long run, that's going to be the best thing.
Hey, Danny with PDC. Between the four of you, you have an immense amount of engineering experience. So I'd like you guys to talk about engineering. Specifically, maybe a project or an aspect of a project that you found particularly fun or interesting that you worked on.
So a project that I really enjoyed or was fun, or it was a project I did a number of years ago. It was university's museum up at the Fairbanks campus. It had a lot of interesting and complex attributes, and humidified building in an Arctic climate is always a challenge. And Ashrae has a very good publication on that. I'm sure all of you know about that. And it was interesting and challenging. It was a lot of work, but I enjoyed the project, and it's a pretty nice building to look at, too. I had nothing to do with that, but interesting systems.
I think for me, well, Steve and I both might come up with the same answer, but we both work on South Pole reconstruction, and then I continued on and throughout Antarctica since 1994, working with the National Science Foundation and meeting the scientists and working on some of the most challenging climates in the world was really a blast. It was fun, and it was fun meeting such smart people and such dedicated people that were working on it. And I had the pleasure of working with Steve. We together, I did a lot of peer review for him. He did some peer review with my stuff, and yeah, it was really a rewarding project. That's probably the best one in my career.
Yeah, the work on South Pole Station in Antarctica and collaborating on some of those activities with Dick was really great, which could take, we could go into that for quite a lengthy time period. But I think the one I mentioned that first came to mind was, this was an older project too, the McNeal Health Center was a new hospital for Kotzebue. And the really great part was the way that whole design process worked. It was really a part of a fundamental change for how the Indian Health Service was going to deliver not just healthcare, but the infrastructure to support healthcare in rural Native communities. And there was a great opportunity to start at the very beginning and work collaboratively with all the stakeholders and the people that were going to use the facility and the people that were going to maintain the facility and review what the design criteria should be and what system options were, and then to discuss the pros and cons of these different system options. And then collectively, I could give them advice as Boyd suggests engineers should be doing, but ultimately we made a collective decision on the best choice for that facility, for that group at that time. And it was really a rewarding experience. And it's fun to go back to the facility now and see kind of how it's held up and how they still do a great job really of maintaining and operating that facility.
It's a lot of fun being involved in a project when you start right from the very beginning and you work with people on their concepts, to what they're trying to accomplish, and help them document it, and help them really patent their ideas, and then watch the whole thing develop all the way through to the end. It's, I think, most rewarding. The last project that I worked on was the emergency power supply system at Providence, and I think that was probably the most rewarding project. It started off with business opportunity assessment, a lot of site studies. It took basically 4 years to just get them to decide what they wanted to do. And I didn't get them to decide, but to help them come to the decision of what they wanted to do and where we wanted to site it. And then another couple of years to design it. And in that particular project, I was prime consultant, which is always a lot more fun because, you know, you're hiring the architect and the structural engineer and the civil engineer. It's a good feeling to know that you have a big impact on a project. But technically, I'm thinking of 2 projects that were kind of like bookended my design career. The first one was the Sullivan Arena. And on the Sullivan Arena, we had 10 air handlers that had to be able to project air from up 130 feet down to the arena where you could walk around. The guy could be playing hockey, or there could have. The thing was designed to do tractor pulls, where there's diesel smoke and dirt on the floor. I don't think they ever did that. But, you know, monster trucks and everything, that was the vision. So you had to have enough air to be able to clear the thing out like it was a giant welding shop. And at the same time, you couldn't have the air move so fast that it caused drafts. And you're moving so much air, you had to be able to figure out how to control all of that HVAC noise. Well, this was back in 1980, 81, and there wasn't an HVAC, there wasn't an acoustic consultant in Anchorage. So it came from San Francisco. And the guy never showed up, but I still had to design this thing. So I sat down with, I went and got 7 or 8 books on acoustics, and I read and read and read and read and read until I finally figured out how to design acoustics. And so I designed the acoustics for it. And when the guy finally showed up and he checked my calculations, he says, "Oh, that was a good job." He says, "You're done." And I was like, yes, that was great. So that was a very fun project. And I used acoustics a lot during the design through my entire career. But at the end, when we had that power plant, we had 4 2-megawatt generators sitting inside of this concrete box. And it was only like 300 feet away from the property line. And we had to hit under 50 dBA at night with all of those generators running. And each generator was like 114 decibels, you know, and if you got 4 of them running, the whole room was just screaming. So it was just like a flashback to that Sullivan Arena. I basically made the entire room a great big acoustic box, and then the appliance, the whole building is just one great big silencer. It was a fun project because I was able to just take what I originally learned and then apply it to a project.
Another thing that I'm curious about, so it seems to me that there's some challenges facing the state of Alaska. You know, BP just left, and climate change that Steve mentioned. What are some industries that you think are either going to diminish or increase in Alaska? And where do you see the state 2050?
Well, the first thing I would toss out is you mentioned 2050, so I'll put a plug in for a book that I encountered a couple of years ago. Actually, I got it at a conference in Iceland at the Arctic Circle Conference, and it was called The New North, the Arctic in 2050, I think it was, or close to that. Anyway, it's a great read because the person who wrote it, I think, is really an anthropologist. And it was a doctoral research project that resulted in the book. But this person took a bunch of several major factors like demographics and resource utilization and energy consumption and things like that, and then he applied it to the kind of mainstream climate models and what they're predicting the climate condition will be like, looking out at 2050, and then kind of envisioning for what the environment or the world will look like in the north at that time. And it's really fascinating to read about whether the population in the north is going to grow or shrink, whether it's going to become a more desirable place to live or a less desirable place, what will be the difficult challenges in the north that are different than what we see today. And a lot of them you already begin to realize. Like just one example I'll toss out, which again gets back into what we might be doing as engineers or how we see the things changing in the state. One of his comments was the north, one of the output of this was that the north would start to become a darker place. It would become a darker place because the snowpack would be shrinking. It would exist for a shorter duration during the year. And since the snowpack, as we all know, is highly reflective, if that's gone, then shucks, we start to look like Hawaii in the wintertime. I mean, when the sun goes down in Hawaii, it is dark. And that's not the case here, which is kind of the beauty of the north. But that's going to change because of the changing ground cover. And I've encountered several people since then that in the course of discussion, they've just mentioned, it seems like it's getting darker where I live now. And they did read the book. They don't know why, but that's what's starting to happen. So I think there's going to be a lot of change in Alaska between now and 2050. And some of it's going to be for the good, but a lot of it's going to mean significant changes in the infrastructure and the design solutions that we put in place. But the really positive aspect of that is that things are changing, and the people best equipped to come up with the new solutions are the people that are in the Arctic now. I mean, you really know what it takes to exist or develop solutions in the Arctic, and you can apply that to a new set of conditions. The old solutions aren't going to be the new solutions in 2050, and that seems to me like a great opportunity for Alaska, really.
Opportunity for engineers.
Yes.
Yeah.
Oh, yeah, a lot of challenges. Unique challenge.
I think certainly development of mining and petroleum, tourism are all going to continue to really grow in Alaska. I mean, it's such a big place. There's got to be gobs of minerals that are undiscovered and oil fields that are undiscovered. So I think for a long time to come, there'll be lots of opportunities for engineers and these kinds of developing industries.
I haven't got a clue. I simply don't know. I don't know.
Yeah, it's tough. The 29th, there's the Economic Outlook meeting down at the Denina Center. And they talk about Anchorage primarily, but they usually give some forecasts along those lines, so you might follow up on that.
I'm sure they could quite out to 2050.
They don't go out that far, no.
One of the things that I used to try to do was anticipate where the money was coming from in the state. My theory was that if I could see the federal money and the state money and I could add it up, I could kind of figure out where construction might be and then maybe reposition ourselves to take advantage of it. That was terrible. I was terrible. I would think that there wasn't going to be anything and money just flooded in. And I was thinking money was going to flood in and it was dry as a bone. So I don't know. Somebody might be able to figure that out. The one thing I do know is that control system in your building is going to be dead in 15 years. Yeah. And those fan bearings are gone in 25. And that boiler's not going to be looking too good in 35 or 40. So you look at all the buildings and all the equipment, and whether, as long as there's people here, you're going to be busy.
Yeah.
Just
That's a good
I wouldn't
point.
worry.
I think one of the things that is really holding us back right now is the dilemma that the state is in with funding. And we'd be seeing a lot more construction projects out there that would give us all jobs if the state had that figured out. Something's got to give. with oil royalties down, there's got to be some kind of, I hate to say the T word, but there's got to be something to provide money to run the state, whether it's a sales tax or an income tax or some magical thing we don't know about. Maybe royalties on minerals, because we know there are a lot of minerals out there. You just can't get to them. But so I think we're going to see a lot of changes, not just going to be engineering, it's going to be economics and finance, some of that too.